of our networking field day 40 presentation. I'll show some demos of some of these things that I just covered. Okay. So look, this is Netris controller. This is the day 0 situation. Hardware is ordered. It's in the process of delivery, and we're waiting on hardware. So we're modeling something in the controller. This is empty controller. And see, inventory, topology, everything is empty. And the first step is to model, to put some initial information into the controller. And so to do that, I'm going to use this Terraform module, because Netris understands Terraform. And we can insert this information through different ways. We can ingest a CSV file. But when using Terraform, this is kind of predefined topology based on one of the common use cases. So this one is for 2-tier Ethernet-based switch fabric. So in this case, we're going to generate infrastructure for 64 GPUs. So it will derive the actual number of switches and cables and everything from this number. So let's put 64. And here we define some IP addresses for like loopbacks, for management, and it will be picking IPs from these ranges. And that's for east-west, that's for backend network. And this part will defines different parameters for front-end network. So basically we need to define how many lift switches we need, how many spine switches we need. We define the things and then we apply. So this window here is SSH terminal into the same controller, into basically this same controller. So this terraforming process is happening on the same machine. This module is calling Netris APIs to create different objects. Everything in Netris controller is object-oriented. So we're creating objects. So we have created this topology, and we're going to simulate this topology using Netris CloudSim.
So this is all Netris constructs. You're not generating device configuration here yet.
Not yet.
Okay.
Not yet. Yes. Very, very good point. I just started the simulation. It takes 5 minutes. So while it's coming up, I'll walk you through what I just did. But you're right. I just created only Netris constructs, no configuration. So controller at this point doesn't know. And in general, actually, controller never knows about configurations. It's not controller's job. Yeah.
That would depend.
No, it actually doesn't know about configurations.
I believe that's how you've constructed your system.
Yes. Yeah. So what did we create? So we created some inventory entries for each server, which is basically the name of the server, and other parameters are just left to default values. There's this custom field which is kind of a data storage. If you're using InfiniBand, we would auto detect GUIDs and some information from InfiniBand fabric, and we will store that information here. But for current purpose, this is not important. And then we have a lot of, we've created some switches. Because we do more stuff with switches, we define more things with respect to switches. So we have a switch name, operating system name, so system knows what operating system to provision. AS number.
Hey, Alex, quick question for you. I noticed in this screen, you've got IP address, and I've seen in other screens where you had IP family. Mm-hmm. How does IPv6 support look? Is it there's certain parts of it that support v6 or across the board? What's that look like?
It's fully supported on services side.
Okay. Oh, so you mean like gateways, like NAT and
Yeah.
like the layer 3 services?
All that is dual stack.
Okay, so but on the actual on this side, like on the management side, it's v4.
Yeah.
Okay.
So these things are with respect to like this is my loopback IP of the switch, my management IP of the switch. So these are IPv4s.
Yep.
Links between switches, they are either unnumbered or they can have IPv4, but we're working on IPv6 support for switch-to-switch links. Why? Because some future clusters that are coming, they need more IPs than IPv4 can support. They will have more links than you can have private IPv4 addresses.
Thank you.
So we created that, and the simulation is loading. We created entries in IPAM, so subnet for loopback, subnet for management IPs, and we have this topology. So topology kind of is just information about how it should be cabled. And we have this concept we call inventory profiles. So
Can I ask a question?
yes.
Will this build cable maps? So this way you can kind of hand the cable map off to your install folks?
Yes. Export cut sheets. Here we have export cut sheets. We also have export labels.
Perfect.
So we can print and stick. So this top part here is the backend fabric, east-west fabric. This bottom part here is the north-south fabric. This middle part, these are GPU servers. In this architecture, we have 8 GPU servers. So this, NICs 1 to 8, each GPU connected to east-west fabric. And NICs 9 and 10, these are production NICs. They're typically bonded from the server side. And 11 is IPMI management interface of the server. We have this inventory profiles. One profile connected to east-west switches, one profile associated with north-south switches, and this is where you define things like what is my DNS server or who can SSH to the switch, but also you define things like these switches should be optimized for QoS and RoCE. And like each vendor has their own, each hardware vendor has their own how you configure RoCE kind of recommendations. And we know what is it for different vendors, and like combination of operating system and this checkbox, tells our algorithm what exactly to configure. So from user perspective, it's just one checkbox. What's gonna happen underneath, like a lot of configuration will be different. Now, we can see that this topology part is changing colors. And if we go to our health dashboard, see what's happening. Controller doesn't know that this is a simulation. Controller thinks that these switches are coming alive and they are getting operating system. And then controller pushes what we call Netris agent on the switch. And then agent, using out-of-band management, kind of calls back home to controller. Controller is usually hosted on-prem in the data center. But the way communication works, switch will kind of call back home to controller. And when that happens, we receive heartbeats, we show heartbeats, and we can see that 22 nodes, which are basically 18 switches and 4 soft gates, already established contact with the controller. And on this side, we can see that a number of critical alarms are showing up. What's happening here, this agent is waking up, and there's this brand new operating system with no configuration, and the agent is like, oh my gosh, no configuration, what are we gonna do? Who I am? Oh, I'm switch number 17. I have these neighbors. I'm supposed to have these neighbors. Okay, let me try and bring some BGP configurations up. Let me see if I can do that. And then both automatic generation of configuration happens and automatic monitoring happens. So not only agent tries to bring up that BGP session, but it starts monitoring lots of things. Like,
Quick question for you, Alex. You were talking about configuration generation. Is that performed by the agent itself and then applied to the switch, or does the mothership, the Netris controller, create the configuration?
but it's done by the agent.
Okay.
Controllers still
Follow-up question.
Yes.
Oh, sorry. I'll let you finish the answer there.
Controller still has no idea about these configurations. Controller can receive information of like, hey, this port is not coming up, but like controller has no idea what was or what is supposed to be configured on that port.
Okay. And then I have a follow-up question. It's probably a silly question, but with your product in place, do your customers still back up their configurations? Do they still need to back them up somewhere?
That's
generated on the fly.
That's a great question. No, there's no backups in our world. No backups of switch configuration. You do need to back up your controller, and controller will create daily backup files, and you just need to copy it. But like there's literally no backups of switch by switch configs. Switch dies, you replace the switch, and the agent is again, oh my gosh, empty switch. Let me generate the config.
Okay. I know of some enterprise networks that also don't back up their network configs, but that's a different story.
Yeah. Okay. So now we can see that now like most alarms are gone. Wiring is consistent with the topology. Surprisingly, all cables are connected correctly in the simulation. No, in physical data center, you would have like our practice shows that like roughly 5% of cables will be miswired on average. And it's a big number at scale. And then you might spend like few weeks of fixing this, but having a list of what is miswired, it's really, really helpful. So now that the fabric is mostly up and running, no alarms, let's connect to some of the servers. Okay, so the way simulation works, you can use your controller as a jump host, and from inside the controller you can SSH to any switch or any server. And in real life, at this point in time, servers would not have operating system, right? Because it is job of another system to install the operating system. But for the sake of training and demo, we bring up these machines with some Ubuntu operating system, so we can execute pings. And these machines have a ton of interfaces, so we use this script called cluster ping. It takes host ID and executes parallel pings across each rail. So like one command and 10 pings, useful. Now host 0 is pinging itself, and obviously all interfaces respond. But if host 0 tries to ping host 1, we're getting timeouts. So on this other window, I will connect. So left and right windows are same jump host. On left side, I'm connected to one of my servers. On right side, I'm connecting to one of the switches, one of the leaf switches. And here, I'll do some show commands. So this is list of VRFs so far configured. And this is a list of VLANs, VXLANs, and bridges so far connected. And I'll go back to the controller to create some tenants, to onboard some tenants and see how configurations change. So as a consumer, as a network engineer, we want to provide consumers a way to easily create these clusters. So this is that construct. We call it server cluster. So in this construct, you put some very simple parameters, just a name, admin, like a local admin for Netris, which data center, whether to use existing VPC or create a new VPC, and then a template. We select this template, and I'll explain I'll show this template soon. And then here, from consumer perspective, we're selecting just few servers, right? Four servers in this case. Add, and this is being provisioned. And let me create one more. Maybe we call this Bravo. And all the same parameters, again, create new VPC, same template. But the only difference that servers from 0 to 3 are occupied by alpha, and I need to select other servers. So the intent here is to, like, simple use case, 2 bare metal subclusters is what consumer is trying to create, right? Simple descriptions. But it's network engineer's job to turn this into VRFs, VXLANs, and all that stuff with the help of Netris. So network engineer defined these templates. Remember, I used the template. As a consumer, I use this template. And this one is example template, and you can, like, different customers do different templates. But the idea of this template is network engineer is telling the system that, hey, for this kind of subclusters, I want you to create one VNet, like one segment for backend networking for east-west, and that one I want you to create L3 VPN kind of template, and I want you to associate that with Ethernet 1 to 8. Now, Ethernet 1 to 8, that's with respect to the model that we have in the controller. That has nothing to do with, like, actual interface names on the server. If you go and if config, there will be different names. And then the template also tells that, hey, I want another VNet in my north-south, and that one I want to be an L2 VPN type, and I want to have this as like a default gateway on that one. And I want one more. I also want to isolate my management, and I want it to be also L2 VPN, and I want this IP to be default gateway for that. Now, in this case, two customers have overlapping IPs, and this is kind of choice of this engineer. And then we can see that in VPC section, we can see that 2 VPCs inside Netris have just been created. See, the time been like 2 minutes ago. And if we go back to this switch, remember we had this show command that showed that existing VRFs. And if I rerun that command again, we will see that 2 new VRFs have been just added to the switch. These 2. And these numbers are aligned with VPC numbers, so it's just like for convenience. And then if we go and check this VPC section, the VNet section, we will see that 3 VNets were created for Alpha and 3 VNets were created for Bravo. So basically, that template is what connects network engineers' world with cloud consumers' world. And with the help of that, cloud consumer is dealing with the simplicity, and network engineer is dealing with network engineering constructs, VXLANs, VLANs, whatever network engineer needs in this case. And if, again, we go back to our switch, we initially had this list of VLANs, VXLANs, and bridges configured. If I rerun that same command, we can see that some additional VLANs, VXLANs bond interfaces were created. So this versus this, right? This compared to this. And we can even see that on some interfaces, even bonding being configured. Why? Because we detected that server has LACP configured, and it's like, oh my gosh, the server is trying to do EVPN multi-homing. Let me configure from the switch side. And if we go back to the server, which was failing to ping its neighbors. So host 0 couldn't ping host 1. If I rerun that, we can see that host 1 is responding on each rail, production interface, management interface. Just like that, host 2 is responding, host 3 is responding, but host 4 belongs in different tenants, so I should not be able to access it. So now that these 4 machines can talk to each other at the back end, front end, a lot of capacity, a lot of throughput, cool. How do we access this thing from the outside, from the internet? So I need to copy this private IP, and I'll go back to my controller, and I'll configure an elastic IP. Okay. I select DNAT. We support source NAT and like different things, but like in this case, we need DNAT, right? Destination NATing. Here we select the right VPC. We select the source. We can do like on like protocol basis, TCP port, but like just a simple case. And from here, we select, we pick the public IP, maybe this one. And it's a pool that network engineer designated for this function. In IPAM, you mark the pool for this function. And we click add, and I need to copy this IP address. And so hopefully this works. So here, see, this window is not using any jump host. This is basically Wi-Fi in this room. So hopefully there is routing. Oh, looks like there is. So, and yeah, and now there is. See? So configuration happened. So I'm pinging from the Wi-Fi through Wi-Fi here. So traffic goes through the internet to our data center in Santa Clara, where the simulation is running. We have this ability of connecting simulation to the world. And just to prove the point, and like who knows, let's create this very simple application on my server. And let me try to telnet to that TCP port through Wi-Fi. Yeah, so data exchange happens and like it actually works. Okay, now we have four more minutes, and I want to use this time to quickly show some of the DPU stuff that we have recently built. So where is it? Yes. So for DPU demo, I'm using a physical lab, not simulation. We cannot simulate DPUs yet. So in this setup, we have these 3 servers. Server 1 has a DPU, server 2 has a DPU, server 3 doesn't have it's regular host. And
are these blue fields?
Blue fields, yeah. Blue field, yeah. And here, this machine, I'm connected to this machine. This is server 3. And if on this machine, I have this, again, this is kind of continuous ping, which is pinging its own gateway, and it's pinging 2 private IPs that are on some VMs behind that blue field. And it's currently failing because I haven't configured much. So I'm going back. Let me quickly show, or actually, let me create a VNet for that. Okay, we need to select the right VPC. This will be VPC4 demo. You can tell it's a physical lab, right? A lot of things configured, like our engineers are using this lab every day. We select admin, and then we add an IP. So this is the IP, this is the default gateway IP address for this subnet. And then here, I need to add server 3, its ETH1 as untagged. Then I want to add server 1. And for server 1, see, because it's DPU enabled, I'm seeing this PF0, VF, these interfaces. So I need to include, I believe I need to include PF0, VF7 for server 1. And for server 2, I believe I need to include PF1, VF7. Hopefully this is right. Yes. Click add, and it's provisioning. It will take some time, and it's still failing because it's provisioning. It takes like 1 minute. While we're waiting, let me show a couple things. There's 1 minute. It should work in 1 minute. In this case, with the DPU, when I added the server object inside Netris, see, it's slightly different. So compared to like regular server that doesn't have a DPU, see, there's DPUs says 0. And this other server, in this case, is saying DPUs 1. And DPU is like a switch, like another network engineering thing. So we need to manage this thing. So we need to have like a loopback IP, management IP, and AS number. There's a way to generate these things automatically in a fast way, yes. And let me quickly show you the diagram of what it is. So, this is server 1. It has a DPU. Server 2 has a DPU, and there's server 3, no DPU. And I have a VM inside server 1 that has this IP that ends with 101, and it's connected to VF7, PF0, VF7, because there's 16 of these PFs, VFs. And on server 2, VM with IP 102, and on physical machine IP 103. We're out of time, and when we go back, we can see that provisioning is done, and
Freaking amazing.
bare metal can ping its gateway, and bare metal can ping hosts behind the DPU. And you can even tell, see the numbers are, there's round trip time is slightly lower with the default gateway than behind, because it's 2 hosts away, two hops away.